From the previous video about n-person game, we know that there are many solution concepts to this kind of game. Now in this video, I'm going to talk about one method to find the solution concept, and it is called the core. So let's start. Before we talk about how we may find the core or the solution concept, let's talk about the dominance. So given two imputations, x and y, we say that imputation y dominates x through a coalition S. So this is the notation. Y greater than x means that y dominates x through the coalition S. So you see there's a small s there. It means that y dominates x through the coalition S if these conditions apply. These conditions mean that first, each member of S, so those who are going to form a coalition, prefers y to x because yi is always greater than xi for all I player who is the element of the coalition S. So it means that those who wants to form a coalition S, they always prefer the reward that is given by imputation Y compared to the reward given by imputation X. So that's why you see yi greater than xi. And that's why player I prefers imputation Y compared to X. Now this inequality here says that the sum of the reward for the players in the coalition, so sum of yi, I is the element of S, must be less than or equal to Vs, which means that the reward that is given by y is reasonable because it is less than or equal to Vs. Remember that Vs is the characteristic function or the value that the coalition S can receive, right? If the sum of the reward is less than or equal to Vs, it means that the reward that is offered by imputation Y is reasonable. Suppose the sign here is greater than. Now this becomes a little bit unreasonable, right? Because if those players form the coalition S, from the characteristic function, we know that they may obtain the value Vs for sure. Now, how is it possible that suddenly they form a coalition and they get a reward which the sum exceeds Vs? Like how or why does that additional money come from, right? You make a coalition, you can get Vs. Now there is a reward that offers more than Vs, so that is not reasonable. Okay, so in that condition, you cannot say Y will dominate X through the coalition S because it is not reasonable to have that kind of coalition that offers the sum of the reward greater than Vs. So that's what is said by the second point here. Okay, so if that happens, it means that X will be dominated by Y. In other words, X cannot be the solution of the game because the player who can form the coalition S will form that coalition to ensure that the imputation Y happens instead of X. Let's look at an example to make that concept clearer. So we have a three-person game, and this is the characteristic function. And then we are given two reward vectors. And now it says show that Y dominates X through the coalition of 1 and 3. First, we need to show that both X and Y are imputations. So you need to make sure that X and Y, they both satisfy the group rationality and also individual rationality. In this case, yes, they are both imputations, but I strongly suggest you to do the check, okay? And then now we observe that these are the two conditions such that we can say Y dominates X through the coalition S. So now it says that Y dominates X through the coalition of 1 and 3. So first check this thing here, yi greater than xi, it is easier. So 1 and 3, y1 is greater than x1, y3 is greater than x3. So yes, this condition is satisfied. Player 1 and player 3 prefers imputation y to imputation x. Now let's take the sum of the reward for player 1 and 3. So it is 0.1 plus 0.1. It is equal to 0.2. And then 0.2 does not exceed the characteristic function of the coalition of 1 and 3. So we say that this is a reasonable reward vector. So y is a reasonable imputation, such that now we have shown that player 1 and 3 may form the coalition such that y dominates x through the coalition of 1 and 3. In other words, player 1 and 3 will never allow the rewards given by vector x to occur because they both prefer imputation y. Now another example is for the land development game on example 13 on the previous video. We are given two reward vectors x and y, and we need to show that y dominates x again through the coalition of player 1 and player 3. Same as before, first we actually need to check whether x and y are imputations. In this case, they are. And then given this characteristic functions for the land development game, and then here are the conditions that we need to check. So it says y dominates x through the coalition of 1, 3. So let's check if yi always greater than xi. y1 greater than x1, so that's correct. y3 greater than x3 is also correct. So this condition is satisfied. Now check if the sum of the reward offered to player I is less than or equal to the characteristic function of the coalition. So yi plus y3 equals 29,900. It does not exceed v13. So it means that the reward offered by the imputation y is reasonable, and 1 and 3 may form a coalition, and they will get a total reward of $29,900. So in this case, we have shown that imputation y dominates imputation x through the coalition of player 1 and 3. So let's apply what we've learned about the dominance to the core. So the core is the solution of the n-person game. It says here that the core only contains undominated imputations. It means that if you find an imputation that is dominated, then that imputation cannot be the solution of the game. Only imputations that are undominated by any other imputation can be the solution to the game. So that is according to the core method here. Now, how can we find or determine the core? Well, an imputation is in the core of an n-person game if and only if this inequality here is satisfied. So before we talk about what this means, let's start by pointing out the important things here. First, you need to make sure that the reward vector is an imputation. And then second thing is that you need to make sure that for each subset S of n, so each subset S of n, you need to make sure that this thing here is satisfied. So that inequality says that for every collision S, in which S is all the subset of n, so remember the subsets can be just each player acting by themselves, two players, and then grand collision, and also the empty set. Okay, you need to make sure that the reward that is offered by this imputation is always greater than or equal to Vs, such that that imputation can be the core. It means that the rewards received by the players in any subset S is always at least as large as Vs. Why is this the case? Well, if this is not the case, then you may find some players who may say, let's form a collision S, and then it will dominate the imputation, right? Like what we have talked about in the previous slides. So to be able to say that this imputation is undominated, the reward vector must satisfy this inequality. Otherwise, it will be dominated, and then it cannot be the solution to the game. So we have learned how one imputation may dominate the other imputation. And then based on that, we know that the solution of the game contains all the solutions that are undominated, all the imputations that are undominated or cannot be dominated by any other imputation. So let's apply that to the drug game here. So in this example, we are going to find what is the core of this game. To find the core, we need to find an imputation or a reward vector x1, x2, x3 that satisfies these two sets of requirements. The reward vector must be an imputation, and the reward vector must be undominated by any other imputation, and we call it core requirements. To be an imputation, a reward vector must satisfy individual rationality and also group rationality. So individually, it must be greater than the characteristic function of 1 act by himself, 2 acts by himself, and 3 acts by himself. And then for group rationality, the sum of all the rewards for all players must equal to the characteristic function of the grand coalition. So this constraints here says that the reward vector must be an imputation. Now for the requirement of being undominated, for being in the core, the reward must be greater than or equal to each subset of the set of all players. For the sets of each player, 1 by himself, 2 by himself, 3 by himself, the constraints are identical to this. The reward that we offer to each player is greater than or equal to the characteristic functions. So we do not write them again. And then for the subset of the coalition of two players, we have 1 and 2. The reward that we offer to them must be greater than to V12. The reward that we offer to 1 and 3 must be greater than V13. And then for the subset of 2 and 3, the reward that we offer to them must be greater than V23. And finally, the reward that we offer to 1, 2, 3 must be greater than or equal to V123. So these are the constraints that say these are the constraints that x1, x2, x3 must satisfy such that that reward vector is in the core, such that that reward vector is undominated. Now let's solve all these constraints to obtain x1, x2, and x3. So the idea is we're going to sum these three inequalities in the box. So we have one inequality that says 2 in the parentheses x1, x2, x3 greater than or equals to 2 million. But at the same time, we have an equality that we need to satisfy for sure. It says x1, x2, x3 must be exactly 1 million. And this is because of the group rationality in the imputation. So it means that if we divide this by 2, now we have the inequality saying that x1, x2, x3 greater than or equals to a million. But from the equality, we know that they must be exactly 1 million. It means that all this inequality in this blue box, they must be binding. Or in other words, at the optimal solution, these signs must be equality. So we have three equalities and then we have three variables. We may solve these three equalities to obtain that x1 equals a million, x2 equals 0, and x3 equals 0. So this is the core for this game. In other words, the core says that we will give the reward of 1 million to player 1, give the reward of 0 for player 2, and also 0 for player 3. Now let's try to find the core for the garbage game. So this is the description of the garbage game, and then we have also seen that this is the characteristic function of the game. Same as before, we need to write down the constraints. First, saying that the reward vector must be an imputation. It satisfies individual rationality and group rationality. And then we need to ensure that the imputation is in the core. We need to ensure that the imputation is undominated, which means that for all subsets of the set of the players, the reward that is given by this imputation is greater than or equals to the characteristic function Vs. Now here we do not write down all the constraints for all subsets because only this constraints matters for the coalition of 3 players. We are going to see very soon why this is the case. But if you like to write down all the constraints for all subsets, that is fine as well. But you will see that you will only need to use these constraints. Okay, so to find the solution, again, we are kind of looking at the inequalities that we are going to add, and then we are going to match with the equality, just like before. So we add the inequalities in the box, and we get that inequality. But then when we are going to try to match it with the equality here, it is there's no way to match this because the equality says that the sum of this must be -4 exactly. But then if you put -4 here, 3 times -4, it is -12. It is never be greater than or equal to -4, which means that you cannot find any solution to all these constraints. In other words, we do not have any imputation that satisfy the requirements for being in the core. Or in other words, the core is empty. There is no solution for this game according to the concept of the core. Now from the previous slide, we see that we cannot find the core. The core is empty, which means that no imputations that are undominated. In other words, we can in this game, we can always find an imputation that dominates the other imputation. So for example, if we have imputation x that looks like this, we can show that this imputation is dominated by y through the coalition of 1 and 2. Now the question is, I would like you to think about this. Can you find another imputation that dominates y? And through which coalition? Because the core is empty for this game, surely you can find that imputation. And then once you find that imputation, let's say z, you can always find another imputation that dominates z. So that's why in this case, in this game, the core is empty. Now let's find the core for the example of the land development game. We are given the description and also the characteristic function of the game. Same as before, we have two sets of requirements. First, that the reward vector must be an imputation, and then second, the imputation must be undominated such that it can be in the core. Okay, so these are all the constraints that we have. And then first we are going to add the inequalities in these blue boxes because we are going to match it with this equality. So that's why we need to find something that sums up to x1, x2, x3 on the left hand side and 30,000 on the right hand side. We take the sum of the inequalities in the blue boxes and then we obtain this inequality, and then we match it with the equality constraint. So now we know that these two constraints, they must be binding. In other words, x2 must be 0. But then if x2 is 0, and then we look at this constraint in the orange box here, if x2 is 0, now we have x1 greater than or equals to $20,000. So now x1 greater than 20,000, x1 and x3 exactly equal 30,000. It means that the core looks like this. So x1 can be any value starting from 20,000 up to 30,000. And then x3 is 30,000 minus x1. Okay, again we get this solution because from the orange box we know that x1 must be greater than or equal to 20,000, sorry. And then based on the fact that this blue box must be binding, so we know that x1 plus x3 must equal 30,000. So by looking at these two conditions here, we find out that the core of this game looks like this. In other words, we have a lot of solutions, but they are all in the core if you give player 1 the money between 20,000 to 30,000, give player 2 $0, and then give player 3 the money as much as 30,000 minus x1. So we've seen that we may find the solution to an n-person game through the method that is called the core. The key is that we are going to find all imputations that are undominated. In the next video, I'm going to talk about another method which is called the Shapley value. So see you on the next one. Thank you.